This is a car. A real car weighs 2,500 kilograms. To put that in perspective, that's about half the weight of a full-grown African elephant. It's doing 120 kilometers per hour on a highway. And right there, see that? Massive obstacle, the kind of thing that would rip your suspension apart. Now, watch what happens. The car just decided to fly. If you show this clip to a casual driver, they think it looks cool. But if you show it to a veteran automotive engineer, the blood drains from their face. Why? Because they know the math required to do this. They know the energy management required. And they know that their current platforms, the ones planned for 2028, can't do it. They are watching a gap open up that they might never be able to close. So how is this possible? And why should you, someone who probably drives a normal car, who probably hits potholes every week and just deals with it, why should you care? Because what I'm about to show you isn't just a cool car trick, it's the moment the rules changed. Let me take you back for a second. In Germany, Carl Benz builds the first automobile. And from that moment on, for 140 years, the Western world has defined what a car is, what it can do, what's possible. Mercedes, BMW, Porsche, Ferrari. These weren't just brands. They were the standard, the benchmark everyone else chased. And when it came to suspensions, how a car handles bumps, potholes, rough roads, the philosophy was beautifully simple. Something hits your wheel, the suspension compresses, energy gets absorbed. You feel less of the bump. That's it. That's been the entire game for over a century. How do we absorb shocks better? Every engineer, every company, every billion-dollar R&D budget, all focused on that one question. And look, they got really good at it. Take Tesla's adaptive air suspension. When this came out, people lost their minds. Sensors reading the road, automatic adjustments, the car literally learning your driving style. Revolutionary stuff. But here's the thing nobody talks about. It's reactive. The road hits you first, then the system responds. It's like a boxer who can only block punches after he's been hit. Mercedes took it further. Their active body control system, this was the holy grail. Stereo cameras mounted on the windshield, reading the road 15 meters ahead. The car could predict bumps and pre-adjust. I remember reading about this when it came out. Engineers were calling it the future of driving. This is as good as it gets. And then, a car company most Americans had never heard of released a video. And everything changed. Because while Mercedes was learning to read the road, while Tesla was perfecting how to react to bumps, some engineers in Shenzhen were sitting in a room asking a completely different question. Not how do we absorb the road better, but what if we didn't touch the road at all? Think about that for a second. For 140 years, the entire automotive industry accepted one fundamental truth. The car has to deal with the road. BYD looked at that truth and said, why? The system is called DEFIES, and when I tell you what it can do, you're going to think I'm exaggerating. I'm not. Response time? Milliseconds. Not half a second. Milliseconds. Processing power? Thousands of signals per second. Your brain processes about 60 thoughts per second for comparison. Hydraulic force? Over 1 metric ton per axle. That's enough force to bench press your entire car instantly while you're drinking coffee in the driver's seat at highway speed. But specs are just numbers. Let me show you what actually happens inside this car when it decides to jump. DEFIES isn't one thing, it's 3 systems working together. And the best way I can explain it is like this. Imagine your car has a nervous system, a set of muscles, and superhuman reflexes. Each one would be impressive alone. Together, they do things that shouldn't be physically possible. First, DEFIES, the nervous system, intelligent damping control. Fancy words for the car feels everything. Thousands of sensors, processing thousands of signals per second. You know that moment in a corner when your body starts to lean, that uncomfortable feeling of being pushed to one side? DEFIES already corrected for it. Before you felt anything, the car flattened itself. It's like having a co-pilot with superhuman reflexes who adjusts everything a split second before you even realize something's happening. Second, DEFIES, the muscle memory, adaptive air suspension, up to 50 millimeters of travel, that's about 6 inches, 12 different height settings, all automatic. Cruising on the highway, the car drops low, slices through the air, better efficiency. Approaching a speed bump, the car rises, clears it without scraping. You never touch a button, the car just knows. Now, here's the thing. These two systems, they're impressive, but honestly, Mercedes has something similar. Tesla has something similar. They're refinements of existing technology. What comes next? This is what stopped me in my tracks. Third, DEFIES, the superhuman reflexes, intelligent hydraulic body control. This is the system that makes cars fly. At each corner of the car, front left, front right, rear right, there's a hydraulic actuator. These aren't normal shock absorbers. These are muscles. Each one can lift the corner of the car at 500 millimeters per second. Each one can exert over 1,000 kilograms of force. Combined, they can lift the entire car off the ground in the time it takes you to blink. Imagine you're driving, 120 kilometers an hour, music playing, coffee in the cup holder. Up ahead, 50 meters, maybe 100, there's a massive pothole, the kind that would bend a rim, destroy a tire, maybe worse. You don't see it yet, you're changing the radio station, but the car sees it. Binocular cameras, LiDAR, scanning the road constantly. Step 1, detection. The system identifies the threat, classifies it, measures it, all in milliseconds. Step 2, decision. The AI calculates, can we go around? No, traffic. Can we brake? No, too close. Can we absorb it? No, too severe. One option left, jump. Step 3, preparation. DEFIES raises the chassis slightly. DEFIES compresses the hydraulics. The car is coiling like a spring. You still haven't noticed anything. Step 4, launch. All 4 hydraulic motors fire simultaneously. 2,500 kilograms of metal, glass, and leather launches into the air. You feel a slight lift like going over a hill. The car lands, perfectly balanced, suspension absorbing the impact. Your coffee didn't even spill. You had no idea anything happened. The car just saved your life, and you were thinking about what song to play next. Because this isn't a car reacting to the road. This is a car making decisions for you faster than you could possibly make them yourself. But wait, jumping is just one thing this system can do. Watch this. Tank turn. The car rotates 360 degrees in place without moving forward or backward, like a tank, like a video game, like something that shouldn't be real. 4 independent motors, each wheel doing something different. The car just spins. And then there's this, 3-wheel drive. The car lifts one wheel completely off the ground while driving. Not a malfunction, a feature. It can move diagonally. It can dance. There's footage of this car bouncing to music like it's at a club. I know how that sounds. I thought it was fake too. Let me put this in perspective. Tesla's philosophy, feel the bump, then react. Mercedes' philosophy, see the bump coming, pre-adjust. BYD's philosophy, see the bump, calculate in milliseconds, and jump over it entirely. For 140 years, the question was, how do we better deal with the road? BYD asked, what if we didn't have to deal with it at all? That's not an improvement. That's a completely different way of thinking about what a car is.
So here's what happens next. Right now, probably as you're watching this, there are teams in Stuttgart, in Munich, in Detroit, taking this car apart, piece by piece, component by component, trying to figure out how to build their own version. And we know that building a system this responsive implies a development cycle that should take a couple of years. Let me explain why. First, BYD builds everything themselves. 75% of the components in a BYD vehicle are made in-house. Batteries, they make their own. Computer chips, their own. Electric motors, their own. Hydraulic systems, their own. Compare that to a typical Western automaker. They buy batteries from one supplier, chips from another, software from a third. Dozens of companies, hundreds of contracts, thousands of integration points. Every handoff is a potential failure. Every supplier negotiation adds months. BYD doesn't negotiate for critical technology. They walk down the hall. But it gets worse. Second, BYD has a multi-year head start. DEFIES wasn't announced in 2023 and built in 2024. It was revealed in 2023, after years of secret development. While Western companies were debating whether EVs were the future, while they were fighting internally about budget allocations, BYD was quietly building something nobody saw coming. The expertise they've accumulated in hydraulics, in AI, in real-time systems integration can't be bought, can't be acquired. It has to be built through years of failures and iterations that BYD has already completed. Third, the patents. BYD filed extensive patents protecting this technology. Even if you could figure out how they did it, and that's a big if, you'd face legal walls that would delay production for years. Think about the people who work at Porsche, at Mercedes, and BMW. Engineers who grew up dreaming of working for these companies, who spent years in school studying automotive engineering, who got the job, built a career, raised families on those paychecks. Porsche just lost 3.1 billion euros in 2025. Tesla's profits have collapsed. Ferrari is limiting production just to protect their margins. These aren't just numbers on a spreadsheet. These are layoffs, canceled projects, early retirements. People who thought they were building the future of driving are watching a company they'd never heard of leap past everything they've done. And the price? The Yangwang U9, $235,000. A comparable Ferrari, $360,000, minimum. And the Ferrari can't jump. The Ferrari can't rotate in place. The Ferrari can't dance. So what does this actually mean for normal driving? For city driving, forget swerving around potholes. This car doesn't slow down, it jumps. On the highway, it beats biology. Humans need 1.5 seconds to react to debris. This system needs milliseconds. It clears the danger before your brain even registers it. And comfort? It kills 80% of body roll. The best Western supercars manage half that. It's not just better suspension. The car doesn't adapt to the terrain. It ignores it. 2,500 kilograms defying gravity. For 140 years, Western engineers accepted a simple truth. The road is rough, deal with it. BYD asked a different question. Does the car have to deal with the road at all? And they answered, by making it fly. Now, imagine where this goes. Pair this with full autonomy, emergency vehicles that leap over traffic, cars that physically dodge accidents before you even see them. The automotive hierarchy you grew up with, Mercedes, Porsche, Ferrari, is being rewritten in real time by a company the West didn't see coming, with technology they still can't match. Those Western engineers aren't just watching a cool tech demo. They are watching their own obsolescence. The question isn't, is this real? It's been in production since 2024. The real question, the one that keeps the competition up at night, is simple. If they can make a car jump today, what are they building for tomorrow?